Okay, so now we move to the next part of our lesson, and this is about skewness. Okay, the shape. Okay, the shape or skewness of a data set can be described using diagrams, measures of location, and measures of spread. So basically, in skewness, what we are trying to do is it's the shape of the data. Okay, so basically, we are describing over here three kinds of shapes. There are three kinds of shape that we discuss under this skewness. So the distribution can be symmetrical. Can you see symmetrical? Or it can have a positive skew, or it can have a negative skew. So I think when they say the distribution is symmetrical, I think you can understand what's going to happen. In a symmetric distribution, the data is going to be symmetrically distributed around a center value. Okay, so if for example, so we can, so I will take first, I will show this to you under in several ways. So first, okay, let's try the topic symmetrical skewness. We'll discuss under symmetrical skewness. Okay, so if you consider a histogram that is symmetrically skewed, how do you expect the histogram? How will it, how will it be drawn? A histogram with symmetric skewness. First one, histograms. So if the skewness is symmetric, your histogram will be what? The bars will be what? So look, how will your bars look? Guys, can you see? So when you look at this histogram, can you see for the symmetric skewness what's happening here? You can see the graph is distributed either side. It has distributed symmetrically around the center value. Can you see? So over here, so this is how a histogram will look if it is distributed, if it is a symmetric distribution. Okay, so next, the second topic I'd like to discuss under histogram, under symmetrical skewness, like I want to show several shapes. The next one, let's discuss about the box plot. Guys, how do you think a box plot will look if you have a symmetric distribution? Now we know how the box plot, you start with the whiskers, right? And then this is the upper quarter, lower quarter, right? In the box plot. And then you have this box, right? And then now when it comes to a symmetric distribution, the data should be equally distributed, isn't it? So then how do you think the median should come? Median should come exactly in the middle. So there should be equal gaps here. There should be equal gaps. So this is how the box plot should look. Okay. And then if we compare the quartiles, if I so in a symmetric skewness, how will the quartiles go? So if you take the gap now, in this box plot, this is the Q1 value, right? This is the Q2 and this is Q3. So if it is symmetric, these gaps must be equal. So in that case, if you compare the quartiles, what do you have to say? The gap between Q2 minus Q1 means the gap. That gap, Q2 minus Q1 gap, must be equal to what? Q3 minus Q2. Are you guys with me? So the gap between Q2 and Q1 must be equal to the gap between Q3 and Q2. So if this condition is satisfied, again, the data set is symmetric. Okay, and then the next one, the fourth one, we're going to talk about the measures of location, the mode, mean, and the median. Okay, the mode, mean, and the median. So what do you have to say? If the data is symmetric, we say the mode is equal to the mean, and that's equal to the median. All of these three measures of location are going to be equal. The mode, mean, and median, if the data set is symmetric, they are all going to be equal to each other. Okay, that's really important. Okay, so these are the main diagrams you need to be concerned, and the rules you need to be concerned if your data is symmetrically skewed. Okay. Right. Okay, so next let's describe about the skewness, the type of skewness. So we'll discuss about positive skewness now. So when it comes to positive skewness, over here you'll see it's data. Your data are going to be mostly distributed around the lower values. Now you know you when you take a data set, you have the lower x value, the middle x values, and the higher x values, right, in ascending order. So what's happening in positive skewness is you will find most of the data towards the lower side, and here you have a lower. I mean, you have a lower amount of data points when the x values are larger. Now in symmetric, you have the data is distributed symmetrically around the center value, right? But in positive skewness, most of the data points are going to be towards the lower side. So if you construct the histogram for a positive skewness situation, how will the histogram look like? Histogram. So how do you think it should look like? The bars. Yeah, how do you think the bars should look? Guys, look what's happening over here. Guys, look at this graph. What do you notice here? Can you see that most of the data values, I think I'll change this. We'll change it slightly. Wait. And in this, you can see it more clearly, right? Can you see what's happening over here? Most of the data values are distributed around, it's distributed around the low x value, because these x values are lower, these x values are larger. Can you see most of the x values are towards the low x value side? So that's why you have most of the data over in this side comparatively than over here. Okay, so over here you can see this is definitely not symmetric, right? So it's more biased to one side. So you can see the lower x values are having a higher concentration. You have more x values which are smaller than higher. So therefore the graph looks like this. And then let's compare the box plot. So what do you think what happens to the box plot when you are drawing when you're going to go for the positive skewness? So guys, how will the box plot look like? When you compare Q1, Q2, and Q3 in the box, how do you think the gaps are going to be placed? Because I need to place the median. You know, this is Q1. And you know, this is Q3. So, you know, if Q2 is exactly placed in the middle, it's symmetric. So the thing is, if it's positive skewness, are you going to mark Q2 closer to Q1? Or are you going to mark the Q2, the median, closer to Q3? How are you going to mark it? So think about it. Is Q2 closer to Q1 or closer to Q3? Just think about this diagram. Okay, so since most of the data values are distributed around the lower end, you'll find Q1 definitely at the lower end. Q2 will also be close to that side because most of the data points are over here. The median will also be close to the lower X value. Q3 will be somewhere over here, which means what? The gap between Q1 and Q2 will be comparatively small. Can you see? And the Q2, Q1, Q3 gap is comparatively large. Are you with me? So this gives the third one, which is the quartile. So when you compare the quartiles with the gaps, what do you have to say? Q2 minus Q1 gap is smaller than Q3 minus Q2. Can you see? Q2 minus Q1, this gap you have over here is smaller than the gap you have between Q3 and Q2. Is this clear? Okay, and then let's talk about the mode, median and mean. Actually, mode, median and mean. So what do you think? Now you can see over here, mode is the most distributed, the most occurring, right? So you can see mode is clearly the one. I mean, you can see the mode should definitely be at what? Is it the lower x value or the higher x value? The mode. Mode is like the bar that has the highest repetition, right? So basically like the highest value here. So you can see mode should come probably like the first here. Can you see? Mode, and then now if you compare the mean, let's talk about the mean. What do you have to say about the mean? And we can see most of the x values are over here, but you have some x values that are at the higher end also. But you know, when even if you have a few x values at the higher end, mean takes everyone into consideration, isn't it? So which means what? Even if you have a few values that are at the higher end, the mean will increase because of these values. So when you have a positive skewness, guys, you need to understand mean is going to be the largest, the mode is going to be the smallest, and median is going to be the middle value. Median is not affected by any extreme values or anything. So over here, mode is the smallest, median, and then the mean. Okay. Okay, guys. So next, talking about negative skewness, data which are mostly at higher values have a negative skew. Okay, so the opposite of negative, positive skewness. So now you have most of the data values distributed around the higher x values, and you can see in the histogram. So the lower x values have a lesser amount of data compared with the large x values. Then the box plot. So you can see here Q1 is going to be the smallest. Q1 is going to be the smallest. Q3 is going to be over here. Q2, the median is going to be what? More, because you have most of the data values spread around larger x values. The Q3 and Q2 are going to be more closer to each other compared to Q2 and Q1. Okay. So Q2 is going to be more closer to Q2. So that's exactly what we've written over here. Q2 minus Q1, the gap is greater than Q3 minus Q2. And then when we discuss about the mode, median, mean, so you can clearly see even from the histogram that the mode is going to be the largest value here now. The largest data value here is the mode. Okay, and then you can see now the the small x values are kind of like the mean is affected by these small x values, right? So mean will be dragged behind, and median, it's not affected by these small values, so it will be in the middle. Okay, so basically you have the smallest value now as the mean. Mean is the smallest, then you have the median, and the mode will be the largest. So this is how it works with negative skewness. Okay, so you can use one or any of these rules to identify the skewness given in your data set. This is clear? Okay. Okay, so the fifth method, there is also a fifth method that we use. We can also find the skewness by using the equation 3 times mean minus median divided by standard deviation. So they say if you get a value of 0, the data is symmetric. If you get a positive value, data is positively skewed. And if you get a negative value, data is negatively skewed. Actually, in the exam, they can even give you a specially formulated equation as well. So they could give you, now these are the normal methods that we use. If they ask you to describe skewness, you can describe skewness by using any of the techniques that we discussed. So you can use the histogram, the box plot. Basically, I think they'll be asking you to perform some kind of a calculation. If they want a calculation, you'll probably go with the quartile calculation and the mean median mode calculation. Okay. So all with these equations. So you'll have to go with these calculations. Okay, so then sometimes they might be even giving their own equation. They can, formulate a special equation and ask you to use that equation and to get the skewness, to calculate the skewness. Okay, so if they give their own equation in such situations, you should use that equation to determine the skewness. Okay, so over here, we will be, most of the time the equation, if we use the equation when they don't give us, we will be using this if they ask the equation. Otherwise, you can use any of these methods to actually get the skewness. So let's actually go for some sums and practice this now. Okay, so we'll move to exercise 3, question number 1. In a survey of the earnings of some college students who work weekend jobs, The median wage was $36.50. The 75th percentile, guys, what's the 75th percentile? The upper quartile, Q3. The upper quartile is 45.75 and the interquartile range is 30.50. They've given you IQR, interquartile range Q3 minus Q1. Use the quartiles to describe the skewness of the distribution. They ask you to use the quartiles to describe the skewness. So you recall what we should do, right? If you are using the quartiles to describe the skewness, you should get the gap between Q2 and Q1 and get the gap between Q3 and Q2. Do you recall? Okay, so first, I think first thing we should do is here is to actually get the quartiles Q1, Q2, Q3 because you can see Q2 is given, isn't it? Q2 is 36.50. Upper quartile Q3 is also given 45.75. But have they given you Q1? No. So how do you get Q1? Interquartile range is Q3 minus Q1. So interquartile range is 30.50 equal Q3 is 45.75 minus Q1. So Q1 is gonna be 45.75 minus 30.50. How much is Q1? How much? 15.25. Okay, so now time to check the quartiles. Let's check the skewness. How do you check the skewness? We have to check the gap between Q2 and Q1 and get the gap between Q3 and Q2. If the two gaps are equal to each other, the data is symmetric. If Q2 minus Q1 gap is smaller than Q3 minus Q2, the data is positively skewed. If Q2 minus Q1 is larger than Q3 minus Q2, the data is negatively skewed. So shall we get Q2 minus Q1? So Q2 is 36.50 minus Q1 is 15.25. How much is the answer? 21.25. And what about Q3 minus Q2? Q3 is 45.75 minus Q2 is 36.50. How much is the answer? 9.25. Okay, so you can clearly see the gap is what? I think you can see the Q2 minus Q1 gap is larger. Can you see? Therefore, Q2 minus Q1 is greater than Q3 minus Q2, which means what? This is a positive skew. Therefore, data is positively skewed. Sorry, it's not positive, right? Data is negatively skewed. Am I correct to say that? Positive skewness Q2 minus Q1 is smaller. Negative skew Q2 minus Q1 is greater. So data is negatively skewed. Is this clear? Okay, let's go to question number 2. A group of estate agents recorded the time spent on the first meeting with a random sample of 120 of their clients. The mean time spent with their client is 31.1 minutes. They're giving you the mean now. Can you see? So the sample of 120 clients, N is 120, the mean time. So mean is 31.1 and the variance is 78.05. The median time, so Q2, median time is 29.7 minutes and Q1 and Q2, Q1, Q2 values are also given. Q1 is 25.8, Q3 is 34.8. Our one measure of skewness is found using 3 times mean minus median divided by standard deviation. Evaluate this measure and describe the skewness of the data. Okay, let's use the, I think you can see we have everything we require, right? Mean is given. Median is Q2, that's also given. What about standard deviation? Have they directly given us standard deviation? No, they've given you variance and you know standard deviation is the square root of the variance. Okay, so let's get it. So skewness 3 times mean minus median divided by standard deviation. So 3 times mean is 31.1 minus median is 29.7. Divide by standard deviation. Standard deviation is root variance. The variance is 78.05 and you root it. Is this clear? Okay, let's get the answer now. That's going to be 0.4754. Do you see? When you type this in the cal, so you get a large decimal 47540, it goes on. So this is 0.475, correct to 3s. Is this clear? Okay, so they are asking you to evaluate this measure and to describe the skewness. So what kind of a skewness do we have? So if you recall from this equation, if you get directly a 0, it's symmetric. If you get a positive figure, it is positively skewed. It's negative, it's negatively skewed. So you can say this is a positive figure. Therefore, you can say the data is positively skewed. This is clear. Okay, so they say the estate agents are undecided whether to use the median and quartiles or the mean and standard deviation to summarize the data. So to summarize the data, either you should go with median and quartiles or either you have to go with mean and standard deviation. So they are asking state giving a reason which you would recommend for them to use. How do you provide this recommendation? So you can see your data is what? It's positively skewed, right? So if there's a skewness, it means there is an effect. You might have an effect from extreme values, right? That's why the data is skewed. So therefore, the best thing if there is a skewness in the data, it's best that you go with what? Median and quartiles, because they will not be affected by extreme value. You know very well that mean is clearly affected. Mean is definitely affected by extreme values. Okay, so you can say here in part B, use median and quartiles. Why are we using median and quartiles? Because of the skewness. Just right, because data don't go to say all the extreme values, because just say because if the data is skewed, it's best you use median and quartiles. Okay, so that's it. Okay, guys, we'll quickly go through question number 3. The following stem and leaf diagram summarizes the wing length to the nearest millimeter of a random sample of 67 birds. So they have given you the wing length and then they have given you the key. So always before using a stem and leaf diagram, pay attention to the key, because the key tells you exactly how you should read the stem and leaf diagram. Okay, so part A, they ask you to write down the mode. So guys, what's the mode? Mode is the most repeating value. So what's the most repeating value? You have 50 thrice, so 51 twice, 52 twice, 53 three times likewise. So check all the values. Who is repeating the most? You can see this 4 over here. You have 4 fours, which is what? This is 64, right? So I think 64 is the most occurring value because the others don't occur as much. So mode is 64. Write down the median. So how do we go for the median? We can use the equation n divided by 2. Our n is 67 divided by 2 is how much? 33.5. You know the rule when you are working with discrete data. If it's a decimal, you should round the answer up. Rounding it up gives us 34. Okay, so now what you do is go for the 34th value. There are over here when they mark 12, it means there are 12 data points here. Here, so there are 10 data points. So this is 12. 12 plus 10, you have 22 data points covered. 22 plus 10, there's 32 data points covered until this point. You have 32 data points. So which means 33, 34 is this guy. Can you see? This is the 34th data point. The 34th data point is 65. So median is 65. Okay, over here, median, the 34th value, that is 65. Next one, quartiles. So Q1 is n divided by 4, n is 67 divided by 4. How much is it? 16.75. So it's a decimal, you must round the answer up, which is what? 17th value. So how do you get the 17th value? You have 12th value until 12th value in the first row. So the second row exceeds, it's 22, right? So we'll have to go with from the first row 12, 13, 14, 15, 16, 17. So what's 17? 56. Guys, do you agree? 56 is the 17th value. So Q1 is 56. Q3 is 3n divided by 4. So 3 times 67 divided by 4, how much is it? 50? 50.25. So rounding it up, it must be the 51st term. You have to round up always, okay? So remember the rule, this is from chapter 2. So Q3 is the 51st value. Let's keep on adding here. We have 12 values. Here we've covered 22, 32, 32 plus 7, 32 plus 7, 39, 39 plus 6, 45, 45 plus 4, 49. Did we cover 51 so far? No, and then 49 plus 8, 57. Right, so then I think you can see we can go for the 51st value after this one. So this is for 49th term. So next you start with 50, 51. Can you see? So 51 is, sorry, 49. So 50, 51. So the 51st term is 81. So Q3 is 81. Guys, do you agree? Okay, and then they ask you construct a box plot to represent the data. So over here, they're not asking us to check for any outliers or any such thing, because I think we can say data points are going very close to each other. Can you see 50, 51, 52, and over here 81, 82, 87, 89, 90, 91, 92, 95, 97, 99 goes very close by. So anyway, if there are extreme values, they should give you the rule that you need to use to calculate the outlier. So over here it's not mentioned. So let's directly go for the box plot. So normally box plot should be constructed with what? With a scale. Okay, so I will just roughly draw this because it's an extremely large case. So normally we mark the scale over here. The scale should be printed and given, and you should draw on top of it. So what's the smallest value we have? 50. The smallest value we have is 50. And what's our Q1? This is 50. And what's our Q1? We found Q1 to be? We found Q1 to be 56. So this will be 56. Okay, and then, so this is 56, Q1. Q2 is 65 and Q3 is 81. 65 and 81. So you need to do this on a scale, okay? This is 81. That is 65 is more closer to 56. Is that correct? 65 is more closer to 56 than it is to 81, isn't it? $65, and what's the largest X value? 99. So even this whisker is longer than the other one. 50 to 56, there was a gap of 6. 81 to 99, it's a longer gap, right? So if you draw this on a scale, you don't have to do any guesswork. You can directly get the answer. So I recommend you to draw on a scale. Okay, so this is the box plot. This is clear. So normally this should be drawn on a square grid on a graph paper. Okay, and then you will get all the points very clearly. All right, and then let's go to the next part. Comment on the skewness of the distribution. So what do you have to say about the skewness? I think you can take, even the box plot shows, right? Q2 minus Q1 is 65 minus 56, which is how much? You don't even need the calculation. You can see it. But anyway, because the box plot shows the skewness, isn't it? So I think Q2 minus Q1 gap is, yeah, you don't even need to calculate. You can say Q2 minus Q1 gap is lesser than Q3 minus Q2 gap, because we can visually see it over here. And therefore data is positively skewed, isn't it? Is this clear? Okay, next on party, calculate the mean and standard deviation. So this is a little bit of a large calculation, because mean for discrete data is sigma x over n. So sigma x in the sense there are 67 data values here. You will have to add every single data point, 50 plus 50 plus 50 plus 51 plus 51 plus 52, 52, 53, 53, 53, 54, 54. Likewise, you have to add all of these guys. Okay, so that's a really long calculation. Normally in the exam, they would provide you the sigma x value, because it would be really a long task to add everything. So can I know the, the sigma x value? If you manually add, you get sigma x as 4,604 divided by total number 67. So divide, we get 68.7164. It goes on. 7164, it goes on. So we'll give the answer. So this is in millimeters, right? So the answer is going to be 68.7 millimeter, near to the correct to 3 years. This is clear. And then they also, not only the mean, they want you to get the standard deviation as well. Guys, how do we get the standard deviation? Standard deviation. So when you can see, I'm going to use the equation that is, we are going to use simply the x value. There's no frequency. So you have to use the equation sigma x square over n minus sigma x over n whole thing square. That's the variance. And then you have to square root it to get the standard deviation. So guys, now again, we have another problem. We have to calculate sigma x square. What do you mean by sigma x square? It's, you are going to add the x values by squaring it. So x square means, now for over here, sigma x square means you have to square the first x value, plus you have to add it with the square of the second x value, you have to add it with the square of the third x value, add it with the square of the fourth x value, and go on until you get the square of the 67th value. Each and every individual x value must be squared and added. Okay, so once again, it's a large process when you will do it manually, but most of the, more in the exam, they would most definitely give that value to you directly, so that you don't have to waste time calculating. So I think over here, we manually calculated that. Okay, so we squared every single x value, 50 square plus 50 square plus 50 square plus 51 square plus 51 square plus 52 square plus 52 square. Likewise for all of this. It's a long process. Okay. Okay, so you're not, anyway, you will not get to do such things in the exam. Can I know the sigma x square value that you got? 328,000 divided by n is 67 minus sigma x was 4604 divided by n is 67. And then you root it. How much is it? We get 13.7274167. It goes on. So you can say 13.7 the millimeters, correct to 3 years. Yeah, sorry, this should be 4604 over 67 square, isn't it? Sorry about that. Yeah. And then only you get this, right? Yeah. This is sigma x over n whole thing square. That answer is only this, and that I corrected to 3SS. Okay, so moving on to part F, they ask you use another method to show that the data is skewed. Guys, what's the other method to show that the data is skewed? We can use the, you could even go with the mean minus median over standard deviation. Even that can be done. Or you could go with the quartile, the actual subtraction. Because we never perform the actual subtraction over here, we describe the skewness simply by looking at the box plot. So Q2 is 65 minus 61 minus Q1, that's 56. How much is it? Q3 minus Q2 is 65, which is, so therefore Q2 minus Q1 is less than Q2 minus Q1, Q3 minus Q2, therefore positively skewed. This is clear? All right, and then let's go to the next one. State giving a reason which of B or E would you recommend using to summarize the data in the diagram. So using B or E. B was what? Median and quartiles. E is mean and standard deviation. So which is the better one? You know, I think we did this previously also. So when you have median and quartiles, they are not affected by the skewness, but the mean and standard deviation, they are affected because of the skewness. So because the data is skewed, we must go with last part, right? Which part was it? Part G. So you can write data is skewed. Data is skewed, therefore summarize using what? This is clear.